Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Mitch Densley, Principal Solutions Architect at Opengear. Opengear delivers secure, resilient access and automation to critical IT infrastructure even when networks are down. The company's provisioning, orchestration, and remote management of network devices through innovative software and appliances enables technical staff to manage their data centers and remote network locations reliably and efficiently. Mitch is an IT professional with many years of experience in cybersecurity engineering, technical training, and network engineering. He designs and maintains secure networks according to real-world best practices, zero trust, defense in depth, IEEE, and OSI standards. Mitch joins us as part of our exclusive editorial segment on generative AI for network management. Welcome, Mitch. Great to have you on today's episode.
Thank you. It's a pleasure to be here.
Okay, great. So let's begin. How does the increasing complexity of AI and GenAI workloads and computing requirements contribute to network performance and security issues?
Yeah, I like starting on a two-parter. This will be fun. And I'm actually right now, I'm coming to you from a hotel in sunny San Jose, California. And this week I'm attending the NVIDIA GTC. It's effectively their AI conference. And I've been, you know, interviewing folks and learning about some of the challenges they've experienced with AI related workloads. And so, from a performance perspective, AI workloads do introduce substantial new demands that traditional Ethernet architectures weren't originally optimized to handle. So, these workloads often involve real time retrieval of diverse and potentially distributed data from different sources. That requires extremely low latency and minimal jitter to maintain computational efficiency and accuracy. So while many current AI infrastructure reference designs prescribe stringent inter-GPU connectivity, and they have detailed network configurations within the cluster that separate out in-band and out-of-band channels, it's unfortunate because they frequently overlook the critical role played by the broader network infrastructure that connects these AI clusters to external data sources, like a customer database, a document repository, or even a user-facing portal. And the implications of latency and, in particular, jitter on AI workload performance are significant. Even a minor fluctuation in data delivery can degrade an AI model inference, causing unexpected bottlenecks, delayed processing, or even significant timeouts. As a result, there's a strong case for revisiting the network architecture and adopting designs optimized explicitly for AI-driven workflows, especially considering endpoint scheduling versus switch level scheduling. You may not know, but endpoint scheduling allows AI clusters more control over the data retrieval priorities, enabling AI workloads to manage their own data pipelines more predictably. Whereas switch level scheduling, it, it's common in traditional network environments. It could inadvertently introduce latency or jitter if that prioritizes network traffic without a detailed understanding of the AI application's real-time needs. So, therefore, forward-thinking network designs should incorporate AI-aware scheduling mechanisms, some thoughtful QoS prioritization, and dedicated high-speed, low-latency pathways between AI compute clusters and the external data repositories they're trying to interact with. This targeted redesign and optimization ensures that the increasingly complex demands of AI and generative AI workloads can be met effectively and reliably. That provides stable, predictable performance, which is necessary for modern AI applications to thrive. Now, the second part of your question, from a security perspective, the rapid evolution of complexity of generative AI workloads significantly increases network security worries. As enterprises redesign networks to cater specifically to low latency and low jitter demands of AI workloads, there's an understandable temptation to streamline those network flows by minimizing inspection points or even loosening the controls just to enhance performance. Unfortunately, though, this approach directly contradicts critical cybersecurity practices such as zero trust principles and microsegmentation that would potentially expose the AI infrastructure to substantial risk. So there's a balance, right? You need to determine what performance is required and intentionally insert appropriate security inspection, whether that's an IDS, an IPS.
Mm-hmm.
I'm not going to tell you what specifically you need to put where, but you need to be very intentional and thoughtful, considering risk and possible types of attack vectors, given what we know now, and our knowledge is ever evolving. So, a broadly permissive corporate network environment where traffic flows chaotically between numerous endpoints can become vulnerable to commonplace disruptions like a routing loop, asymmetric traffic patterns, or unfortunately, even denial of service type of floods. So, unless you carefully inspect and filter out those disruptions, they could leak into the AI side of the network, significantly disrupting those AI operations and introducing latency spikes or outright downtime. And when AI racks are powered in the megawatt factor.
Mm-hmm.
I remember when I got started in the industry, we talked about megawatt data centers. And now we're talking about megawatt racks and potentially soon megawatt single workload servers. So it's important to be thoughtful about the level of inspection you introduce and the types of attacks you're trying to mitigate so that those workloads remain functional. Because if they go down, the costs associated are extremely significant, right? And so I feel like there's merit in thinking about segmenting off the network traffic for AI data retrieval. This is adhering greatly to microsegmentation or just straight up segmentation principles. There's a saying, the most secure network is one that's connected to nothing. Unfortunately, that's a network no one can really use. So start there and
Yep.
then judiciously add in the interconnections required for humans to interact with the AI
Mm-hmm.
workload to access data it needs to retrieve, and so on, right? So a trust but verify strategy remains essential. So placing those inspection points strategically is a wise approach.
Mm-hmm. Wow, interesting. I think you summed up a lot of interesting points there. There are two that caught my attention. The first one is you spoke about out of band networks. Can you explain what these are and what's the other counterpart? How do they differ?
Yeah, happy to dive into that a little bit. You know, Independent out-of-band networks, they provide a specialized and secure way to manage your network infrastructure. And those are separate from production traffic. Talking about segmenting off the networks, right?
Mm-hmm.
The principles around segmenting AI workloads are really derived from the same principles that created out-of-band networks. And at Opengear, we have a smart out of band solution that highlights out of band. And I'm not referring when I say out of band to the physical topology and signaling method, baseband versus broadband, but it's really isolating the purpose of that network and keeping it dedicated for specific functions, be that management, administrative, or dedicated to AI. An out of band network, it differs from the production network because the underlying cables, the switches, the LAN, and even the WAN connectivity is entirely separated from normal operational traffic. And it provides significant advantages. From a security standpoint, isolating that management traffic, it reduces the attack surface and it shields critical management interfaces, and especially the ones that don't inherently have security built in. So, isolating ensures resilience, and a failure or breach in the production network doesn't automatically compromise administrative access. So, your ability to troubleshoot and perform recovery efforts remain viable even during a severe network disruption. But, as I
Mm-hmm.
said, complete isolation isn't always the answer either, right? So be thoughtful and strategic about the interconnections you're going to build between the out-of-band network and the devices that drive the production network. And at these critical in interconnection points, robust filtering is prescribed, right? Something with strict role-based access controls is essential. Something that does effective and detailed logging is essential. And so, with these principles implemented, your production network and the supporting out-of-band network can help keep your environment, very fault tolerant because of the multiple layers of redundancy, failover. You'll be able to handle outages and disruptions gracefully, right? This design, however, it adds complexity, and so, this is a thing that Opengear really shines at. Our mission revolves around simplifying sophisticated out-of-band solutions, allowing organizations to confidently manage and recover their infrastructure efficiently, securely, reliably, regardless of the state of the primary network. It's also worth noting that the pioneers within the AI space, if you look at their reference architectures, they've wisely embedded independent out-of-band into their designs. AI compute pods often require low-level secure network access just to provision and configure the switches for initial operation, and then you can move on to the compute side of the equation, which everyone is excited about and focused on, but you have to securely bring up that network first. And so
Yep.
99% of the time, you might forget that there's an out-of-band network even part of the architecture, but it functions as your insurance policy. So when the unexpected hits, having all that reliable, separate connectivity as a lifeline can make a significant difference between a brief interruption or a prolonged crisis.
Wow, amazing. So you did mention earlier another point, which is about being traffic aware. So guys handling all the or data centers handling all these traffic flows have to be aware which are the traffic flows that come from AI applications, AI workloads. So does that mean that you basically have to really filter through every flow that every packet that traverses the network? Would that increase the processing loads in the network?
I would say potentially. If you're trying to use general purpose network infrastructure to do the level of inspection I'm talking about, then it could significantly improve or increase the processing, uh, adding latency, slowing down traffic, and ultimately, causing disruptions to the AI workload. So when I say being thoughtful about the inspection points you're going to introduce, you also need to be thoughtful about the hardware or software that's going to drive that inspection. And it needs to be purpose built for that purpose. This is why in network security we have dedicated firewalls instead of routers with ACLs. Both can filter, but a dedicated next generation firewall is much more capable at doing that fast, efficient, and accurately. Because attacks can masquerade as different types of traffic, and attackers are intimately familiar with the gear that exists in everyone's network. And so they're researching bypass methodologies and ways to obfuscate attack traffic in such a way that it looks like perfectly legitimate traffic. And I could point out, attacks of the past that are kind of cute, like the ping of death, if you've never heard of that. It's just a ping packet, but it's oversized, and it can crash the TCP stack of not just the destination device, but even intermediate infrastructure. Now that's a very old type of attack, but it's quick and easy to describe. There's much more sophisticated ones now, some as simple as such a ping of death, but they're equally as devastating.
Wow. So, we hear a lot about, when it comes to managing AI related traffic, that the traditional networking solutions may no longer be effective or, adequate in managing these workflows the way we want it, and also in ensuring the network outcomes are still there. So, what do you think about this? Do we really need to move to a completely new networking architecture, or is it like an incremental improvements?
Good question. From a security perspective, I think dedicated hardware that is new and innovative, there's vendors out there with AI specific uh, security devices. I think those are absolutely prescribed. But beyond that, traditional network solutions such as conventional switches and routers, they're not inherently incapable of supporting AI workload connectivity and throughput. In fact, they're exactly what's recommended for the primary in-band communication between an AI cluster and the associated infrastructure and end user services. However, these traditional network products fall short when used for dedicated, secure out of band because they're not purpose built for that function. Just like the security devices need to be purpose built for that function to do it safely, fast, right? Securely. And so, conventional network equipment really is poor at role based access controls, almost non-existent activity logging for essential security auditing, and they often lack the robust resiliency and failover capabilities, all of which are critical in managing AI infrastructure effectively. Now, while the specialized AI hardware often includes standard IP-based management interfaces, they'll often get labeled as a BMC or a baseboard management controller. Those require some vendor native management software to be able to access it, right? Now, some devices also include a low level console, something that is non IP based, serial, sometimes the interface is USB, right? And so managing all of these and connecting to all of these securely, consistently, efficiently, it's essential. And at an Opengear, that's our unique approach, right? We address this challenge by providing a secure management overlay. It's in principle an SD-WAN for BMC access, and it's resilient, right? In that it can remain up through disruptions or state changes or reconfigurations to the underlying production infrastructure. So critical management and monitoring software is able to maintain reliable access to both the IP-based interfaces like a BMC as well as the non-IP-based console interfaces so that when the bad day happens, Opengear enables you to connect in or your automation to flow through, diagnose, and remediate whatever that outage is, right? And bring the full network back to production availability.
Wow, that's insightful. You mentioned a couple of times about Opengear's solutions in this space. So we are kind of intrigued. What's your full suite of solutions, and what are the components that you offer for CSPs as well as enterprises?
Yeah, we take both a software and a hardware approach. We feel it requires both. The hardware is what's going to give you the natural interface connectivity and enable you to speak native protocols to whatever the device is, be it a console, be it a PDU, right? Extract telemetry from them, operational state from them, and then surface all of that in the software. And the software is the orchestration layer. It builds the overlay network. It admits traffic into the overlay. It audits all the behaviors of that traffic or the operators that are generating that traffic. And then when necessary, shuts that down. So Opengear is not the same, however, as a network IDS or IPS, intrusion prevention system, as a generic term, representing something that is signature based, is aware of the myriad of attack types, and can identify attacks and shut them down. We do take a prevention strategy, and so preventing bad things from even entering the environment is absolutely our focus. But you would be wise to incorporate that trust but verify strategy through a signature based or a heuristics based, or let's go modern, right? An AI driven security platform that is capable of identifying threat tactics or TTPs, tactics, techniques, and procedures that are indicative of different types of attacks, making a security professional aware that these types of attacks are happening, and then giving you the ability to continue to monitor and let it happen for a period of time to help you build out your understanding potentially of who the attacker is or what type of attack they're trying to launch at you, and then take isolation actions to quarantine the workload so that you can do your incident response, inspection, triage, and cleanup. And since you mentioned, cloud service providers, they they're not terribly different in some ways from a traditional enterprise data center. I would say their differences, though, become very apparent when we start to look at scale and complexity. A cloud service provider must deliver AI workloads with extremely low latency, consistently high performance, and superior availability, all within a secure, compliant, multi-tenant environment that's globally
Yep.
distributed. At Opengear, we understand that CSPs rely heavily on automation, not only for deployment, which we would call your first day, but also for managing unexpected disruptions, which we would call your worst day, and then for managing optimal operations at scale, which we would call your everyday. To achieve this,
Wow.
CSPs need deep visibility into telemetry, accurate connected resource inventory, a precise control over the infrastructure, alongside a seamless integration with existing automation and orchestration platforms. CSP solutions need to rigorously adhere to industry standards as well, in addition to, in some cases, nation specific security and compliance regulations. Open solutions are intentionally designed to meet these demanding requirements. By providing secure, fault tolerant, high performance management capabilities, we empower the CSP to efficiently handle AI workloads, infrastructure provisioning, and rapid response scenarios, whether it's their first day, worst day, or their everyday.
Wow. I think these are some really great insights. Looking at how AI workloads are being the complexities basically that are involved in managing AI workloads. I think we covered quite a number of topics today. I probably just have one small question. When we say blanketly AI workloads or AI applications, are all AI applications the same? Do they demand the same level of scrutiny, and do they have the same impact on the network, or are there different grades, different classes of AI applications? And do you see some more challenging than others?
Yes, great question. Their AI workloads are different, and it's ultimately what you're doing with that workload. There's the AI cluster as defined, and that would comprise the compute, the GPUs, which you could argue is compute, the infrastructure that interconnects all of that compute. That's actually an isolated network by design if you look at NVIDIA as reference architectures. And so what goes on there is very prescribed, right? It's a fixed known entity essentially, right? Heavy data processing, lots of math, physics. Outside of that, then you've got connectivity to storage. But to your question, like different types of workloads, like what do people use AI for? So if we're talking about deploying an AI agent to drive a portion of my business, let's say I have a significant customer facing presence and I engage with customers and field questions, I might be tempted to deploy a chatbot.
Yep.
And that
Yep.
chatbot should be intelligent enough to understand questions, should be enabled enough with the access to data to answer those questions both securely and rapidly, because any delay, your user's going to walk away. And the difficulty when people get into building a chatbot is the chatbot might mention your competitor, and you don't want that, because the chatbot references a model. The model is built typically by some other company. If you're consuming an open source model or even a closed source model that you didn't self design and build. And so then you take that general purpose model and you want to then adapt it to your specific business, your industry, and to incorporate your data and not any data you don't want the chatbot to reveal or communicate. And so training is a heavy action that was the only way a few years ago to tailor your AI application to your specific needs. Now we've got a few new strategies that are, in some cases, faster and less computationally heavy. But training was as I'm at the NVIDIA GTC conference this week, it's still a huge discussion point.
Yep.
But more broadly, there's a lot of different types of uses and use cases for AI. Image generation is another one. Maybe you've seen some of those kind of silly images that include words that aren't words, or a person with
Yeah.
five hands. And those are evolving at the same time, but they are inherently different. The models they use are different. Yet, the problems from a network perspective and a security perspective aren't really different, given those two types of AI workloads. But we're coming up every day with new use cases for AI, new workload types. And so, even though what I'm saying right now is applicable right now, that might change next week.
Yep. Wow. Yep. I think at the pace things are going right now, I think what you said is really very true. And you know, we are already seeing so much attention. People are already moving from Gen AI and talking about agentic AI, and that's a whole new ball game altogether. So I guess, you know, we don't know what's going to be the main thing, the next big thing in a couple of months down the road. So, yep. I
All I can
guess,
say is buckle up and hang on. It's a fun and exciting ride. And
yep.
when we say it's the future, or it's going to be as transformative as the internet, as cell phones for all of our lives, I think we're underestimating when we make those statements. And I'm not a gloom and doomer. I believe there will be negative from AI. There already is, right? There's Worm GPT, if
There
you've
are.
never heard of
Yes,
it, that
yes,
can give you malware.
yes.
But in aggregate, I feel strongly that the future is bright, and we're all going to have better quality of life, better capabilities, and hopefully new and fun ways to spend our time.
Yep, exactly. I mean, deep fakes aside, I guess AI does make everything much easier than it used to be. So we're all thankful. And yeah, I think, you know, guys like you are around to make sure that things become even more seamless. So I guess, you know, with that, we have come to the end of our podcast today. So thank you so much, Mitch, for joining us today and sharing all this with us.
It was my pleasure, Tara. Thank you so much for having me on. And um, I just want to impart to your listeners, get interested in this space if you're not already. I was watching a similar podcast with Neil deGrasse Tyson, you know, a famous astrophysicist, and he was talking to a gentleman about ChatGPT, and Neil asked the question, "What do you use it for?" And the answer was, "I use it for everything. I ask it every question I can think of. You know, everything from party planning to scheduling my child's learning development to how do I best respond to this email." All of that feeds it, all of that helps it, which in turn helps you. And so don't sit on the fence, don't sit on the sidelines, get involved, use the AIs that are available to you. They're each different, they each have their own strengths and weaknesses, and the more you use it, the better it'll get, and the better your life will eventually become in the end.
Wow, I'm so glad you said that. You know what? I find myself doing the same actually. I'm basically going to ChatGPT to ask even more, even the most obvious, things, just to
Yeah.
be on the safe side. I don't know. I was just thinking like, just like maybe 6 months ago, this thing didn't exist, and we were not using it even like 5 minutes in a day. But today, it's like it's one of the first URLs to go up, on my screen. ChatGPT. It's just there on standby because I'm just going in there for every other question. So I'm glad I'm not the only one.
You're not. No, I appreciate your approach, and I mirror the same.
All right. Okay. So thank you again, Mitch, and to our listeners, thank you guys for listening. If you want to learn more, visit opengear.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye bye.